Hello class, this is Wade Renando again with Chapter 2 on Globalization and Diversity, Geography of a Changing World. I hope you enjoyed the first chapter. If you have any questions about anything, you're more than welcome to email me. And again, this is a video PowerPoint presentation I post on YouTube to help augment and supplement the book. You don't have to go through these videos if you don't want to, but they help walk you through each chapter in the book, and it might help you understand them a little better. So chapter 2 deals with physical geography and the environment. Geography is a broad categorization about the study of the Earth in general, and geology is about the physical features of the Earth, such as plate tectonics and mountains and else like that. We have a lot of geological processes. Physical landscape features are constantly changing, often too slow for people to realize, but they are nonetheless changing. Mount Everest is growing slightly every year. The Appalachian Mountains and some others are shrinking and eroding. And human activities also have a significant effect on our environment. Cities are growing all across the world, and urban areas are transforming what used to be untouched areas of the earth. And there's also demand for basic resources that's destroying natural environments such as rainforests and so on in order to better suit the needs of people. This is a picture of Mount Brono in the morning, which is in Indonesia. Plate tectonics is the process. Basically, the Earth has large plates on it. You can imagine if you had an eggshell and it had some cracks in it. That's somewhat like the crust of the Earth is like. And these large plates are slowly moving towards and against each other, slowly changing the surface of the Earth. In the Atlantic Ocean, there's an area called the Mid-Ocean Ridge in the middle of the Atlantic that comes up, and the Atlantic is actually shallower along the mid-ocean ridge than it is closer to the continents. And as these plates move away from each other, lava from beneath the Earth's crust comes up and meets with the ocean, and then that cools, and the Atlantic Ocean is growing at about 3 feet per year, and the Pacific Ocean is shrinking at roughly 3 feet per year. So when you have a plate that pushes underneath another plate, that's called a subducting plate. And a subduction zone is an area where you have a plate being pushed underneath another area. The Pacific plate is being pushed underneath the South American plate, and that is called the subduction zone. And that subduction zone is leading to earthquakes in Chile and other parts of South America, and also pushing up, which creates the Andes Mountains. So that's an example of a subduction zone. This is another picture of various plates around the world. The Pacific plate is a very large one. The Nazca plate is another large one. This here is the Nazca plate, and it's pushing against the South American plate. And that is, again, a subduction zone that's creating earthquakes in that region. The mid-ocean ridge in the Atlantic is right here, and this is the area that's slowly splitting apart from each other, causing the Atlantic Ocean to grow by about 3 feet per year. And this is the African plate, the Eurasian plate, and so on. Again, when you have plate boundaries that converge and push against each other, that's one plate moving towards another. Mountains are often formed. The Andes are an example of this. The Himalayan mountains are also an example of this. That is the Indian Ocean plate being pushed under the Eurasian plate. And subduction zones are where you often have the most powerful and strongest earthquakes in the U.S. This is a picture of an earthquake that struck Chile in, I believe, 2010. The region is vulnerable to earthquakes, so they actually have very strict building codes to try to protect residents so the buildings don't fall down during major earthquakes. Japan is also an area very prone to earthquakes as well, and California. A divergent plate boundary is the opposite of a subduction zone. That is when you have two plates moving away from each other, like we talked about in the Atlantic, in the middle of the Atlantic. Other areas that are near divergent plate boundaries is Iceland, That's near a divergent plate boundary, and the Rift Valley in Africa is also a divergent plate boundary. These are plates that move apart and that can sometimes create mountain ranges and often creates volcanoes. Iceland has harnessed a lot of the steam and heat that they have underneath their country and used that steam from this divergent plate boundary to heat up water and generate steam that then turns turbines, and they have what's called geothermal power based on the natural springs that they have in their country. Yellowstone National Park is also an area. It's technically a large volcano or a low volcano that creates large amounts of geysers and also hot springs in the area. That's something you could hypothetically convert into energy if you wanted to. So a while back in 2010, there was a massive eruption of a volcano in Iceland, and it spewed tons and tons of ash into the atmosphere, and it actually grounded planes for weeks and caused lots of disruption in air travel. And I remember watching TV, and they were talking, almost every talk show had some guest that couldn't make it because they couldn't fly because of this massive volcano that erupted in Iceland that was disrupting air travel for over a week. When you have two plates that kind of rub against each other, we're not necessarily pulling apart and not necessarily one being pushed under another. That's called a transforms plate boundary. And these plates grind against each other. And the San Andreas Fault is an example of that around San Francisco. These areas are also vulnerable to earthquakes because of these transform plate boundaries. San Francisco had a major earthquake in the late 80s, 1989. In fact, they had it during the middle of the World Series that was going on in San Francisco at the time. A few dozen people were killed, but considering the strength of the earthquake, it could have been much worse. San Francisco is another area that's vulnerable to earthquakes, so they have very strict laws on how buildings must be built so they can withstand them. A long time ago, millions of years ago, all of the different continents were united onto a megacontinent called Pangaea. And over about 100 million years ago, a little longer than that, they started to slowly drift apart and it broke apart into the numerous continents that we now have. But the reason why it looks like South America and part of Africa could fit together almost like a jigsaw puzzle is because at one point they were part of the same continent, Pangaea, and then they slowly broke away and have been moving apart for hundreds of millions of years. So we have different kinds of mountains. Two main mountain types would be folded mountains and fault block mountains. The Appalachian Mountains are an example of folded mountains. These are mountains where you don't typically see exposed rock and the crust of the earth is bent but doesn't break. And then the Rocky Mountains are the opposite. These are fault block mountains. The Andes would be another example of that, where you have breaks in the Earth's crust. The mountains are usually typically higher, and you have a large amount of exposed rock. The Rocky Mountains are interesting because in many mountain ranges, you have a slow, gradual increase, and you have hills that become larger, then they form small mountains, then they become larger, such as in the Himalayas, while in the Rockies, it's dead flat and relatively flat prairie, and then boom, you have these massive mountains, the Grand Tetons and other Rocky Mountains that just kind of come out of the prairie out of nowhere. Lewis and Clark, when they were exploring the West, could see the Rocky Mountains come out of the prairie days before they even got there because you could see the Rocky Mountains come up from so far away. So it's a little unusual to have a relatively flat area and have such an abrupt increase in the mountains like we have in the Rocky Mountains and in the Grand Tetons. The Grand Tetons is a national park that is adjacent to Yellowstone, and they're very impressive. If you haven't seen them, you can see both parks in one trip. They're very interesting and very beautiful and worth seeing. So here's some more information on plate tectonics. On the top, you see areas where you have earthquakes, and they tend to focus around where two different plates meet, especially at transformative plate boundaries and subduction zones where you have one plate going under another. And you have volcanoes often roughly in the same area, although not always. There are some volcanoes that are not necessarily near a specific plate, but usually you have earthquakes and volcanoes in areas that are near where plate boundaries rub into each other or bump up against each other. So we mentioned because of these earthquakes, a lot of areas have to build very difficult, strong buildings that can withstand earthquakes. Seattle is an area that hasn't had a major earthquake in a long time, but it is an area that scientists believe could have one. Interestingly enough, one of the largest earthquakes to hit the U.S. was in the Midwest in Missouri in the early 1800s, around what is now St. Louis or Memphis, or roughly the Tennessee-Missouri border. There was an earthquake that was so massive it actually pushed back the Mississippi River and altered the course of the Mississippi River permanently. At the moment, this was a very lightly populated area. Some French fur traders and some Native Americans were in the area, but because there weren't any massive cities, that's when you typically have the major destruction caused by earthquakes. It was lightly populated, so there were some people who were injured, but there were few, if any, casualties related to that massive earthquake because it was mostly wilderness. Earthquakes and volcanoes, again, are dangerous. Haiti had a massive earthquake in 2010 that unfortunately killed at least 200,000 people, mostly because of buildings that were built with relatively poor standards, buildings that weren't built with proper concrete, without proper reinforcement. The earthquake was 7 in magnitude on the Richter scale, which is moderate, not incredibly strong. But because of how poorly some of the buildings were made, it unfortunately was a very deadly earthquake. On the right here, you can see someone shoveling volcano ash from a volcano. A volcano ash, interestingly, can be moved into cement, and it can make very strong cement that can actually lead to many strong buildings. Many ancient buildings in Rome were built with cement from local volcanoes. That's made them very strong. This again is the 2010 earthquake in Haiti, caused significant destruction. The U.S. Embassy in Haiti was undamaged. It was completed shortly before the earthquake. A Haitian-American architect out of Miami helped design it, and it was designed to withstand earthquakes and hurricanes. This island usually gets hurricanes more than it gets earthquakes. Earthquakes are relatively rare, but this is an example of how you can build buildings to withstand earthquakes and hurricanes also, for that matter, if you build them properly. This also served as a makeshift emergency center for different people in Haiti, and the embassy was used as an emergency hospital and basically first aid center. So we talked a little earlier about there are some benefits to volcanoes, and that is you can use volcanic ash to make incredibly strong cement. This is a picture of a large building in Rome that was built in the 1st century AD. And you can see here it is still standing and relatively intact. And my parents went in there when they were on vacation in Italy, and they noticed that when you walk inside, it's significantly cooler. It's such a large stone building, it's almost as if you're walking inside a cave. And the building has a little hole in the top, and that lets some of the heat escape. And it's a very well constructed building going back to the 1st century AD, the Pantheon in Rome. So global warming, first of all, there are really no reputable scientists in the world who do not believe in global warming and believe that it's caused by human activity. The evidence is beyond overwhelming. Most people, if anyone any scientist who disputes it, is probably being paid by oil or fossil fuel industries. Just like in the 90s, there were some scientists and doctors who were claiming cigarettes were not addictive and didn't cause cancer, but they were, of course, paid by the different tobacco companies to say that. So human activity is closely linked to a rise in global warming and an increase in CO2 and methane and other greenhouse gases in the atmosphere. And humans are almost certainly going to have to adapt to a future that's warmer than it had been in the past. This is an example of a polar bear on the bottom left. Polar bears have been struggling because of warmer temperatures because there isn't as much ice cover, and it's forcing them to swim further for food, and this is burning calories. And some polar bears have actually begun to migrate south, where they're interbreeding with grizzly bears, and they're creating growler bears. Well, on the bottom right, that is a hybrid of a polar bear and a grizzly bear called growler bears. Hybrid bears usually are sterile and cannot have any offspring themselves, but this is an example of how animals have changed and adapted to a changing climate. So there are some climate controls that basically determine what the temperature of the Earth is. The sun is about 94 million miles away from the Earth. We are actually closest to the sun, about 93 million miles away during the northern hemisphere's winter, and we're further away from the sun during our summer. And what determines how warm the Earth is not how close you are to the sun. The distance is insignificant, but the angle of the sun. The longer the days and the more directly the sun hits where you are on the Earth, then the warmer the temperature is, and the more it glances off, and the shorter the days, then the colder it is. So incoming solar radiation is called insolation, and that's essentially just shortwave solar power. And the sun's rays take about 8 minutes from the sun to reach the Earth. That's, of course, traveling at the speed of light, about 94 million miles away. And some of that is deflected into space, and some of it is absorbed into the atmosphere. And shortwave solar radiation is absorbed into the Earth's surface, and then that warms the atmosphere with long wave radiation. So some of the energy from the sun is reflected into space, and some of it is absorbed. The cloudier the Earth is, the more it is covered, and the more it is reflected into space. Also, snow, because it's white, reflects heat back into space as well. So as we lose snow, we lose our ability to reflect heat, and it actually increases global warming when you have less snow to reflect the solar radiation back into space. This is another good diagram of what the Earth looks like and what the rays of the sun look like. As you can see here, as you are further away from the equator, the sun's rays hit you more at an angle, and the closer you are to the equator, the more directly the sun's rays hit you. The equator, of course, is the dividing line between the northern hemisphere, which is here, and the southern hemisphere, which is here. The equator divides the Earth into two equal hemispheres, north and south. And then there are different degrees of latitude, and these are basically, starting at the equator, degrees running north and south of the equator. 90 would be pointing straight up, that would be the North Pole. Anything that's 45 degrees north or south will be halfway between the North Pole and the South Pole. So Traverse City, Michigan is roughly on the 45th parallel north latitude, meaning it's northern. The lower peninsula of Michigan is roughly halfway between the equator and the North Pole. The Earth is tilted at a 23.5 degree angle, and if the Earth was perfectly straight, we wouldn't really have the seasons that we have. We wouldn't have the variation in temperature. It would be relatively stable, similar temperature year-round, somewhat like it is along the equator. There is also the degrees of Tropic of Cancer and Tropic of Capricorn, and these are lines north and south of the equator, about 23 roughly degrees north and 23 degrees south. And if you're within this tropic region, that means at some point in the year the sun's rays will hit you directly. So if you're in the northern hemisphere, the sun is directly overhead on the first day of summer, roughly June 21st, and it's the opposite on the Tropic of Capricorn. If you're in the southern hemisphere, the sun is directly overhead, roughly December 21st. So the longest day of the year is the day where on the Tropic of Cancer, the sun's rays will be hitting that area directly. And of course, the fall and winter equinox is when the sun's rays are directly above the equator, hence you have an equal amount of sun in the northern and southern hemispheres. So latitude, you have to remember, lines of latitude run parallel to each other, and they run east-west, but they measure north-south. Try to envision rungs on a ladder. a ladder takes you up and down, and the rungs on a ladder are an equal distance away from each other and parallel to each other. So try to imagine latitude as rungs on a ladder. They go up and down. They are parallel to each other. Interactions between land and water. The sun's rays come and hit the earth, and water heats and cools more slowly than the earth does. And when the sun's rays hit the earth, this can lead to water evaporation. The water is evaporated into the air and then eventually comes down as snow and rain that is absorbed into the earth or rolls into rivers and lakes and eventually the ocean, where it is evaporated again. So you have this cycle of water being evaporated into the air and then coming down as rain or snow, being absorbed into the earth or the ocean or lakes, and then being evaporated again. Where you have a climate that's close to the ocean, you usually have a more moderated climate. It usually doesn't have the temperature extremes that you do when you're further inland. Seattle, Washington is an example of what we would call a maritime climate, relatively moderate climate. Rarely gets below freezing, rarely gets above, say, 70, 75. London, England, and Paris, France, Ireland would be another example of moderate maritime climates. And then the opposite of that would be what we would have in Michigan, a continental climate. That's when you're usually deep in the interior of a continent, far away from the moderating effects of the ocean, and then you have typically 4 distinct seasons: warm summers and cold winters. And that's definitely what we have in Michigan. So a low pressure system is basically hurricanes and typhoons are massive storms that typically start over the ocean. Hurricanes is a name for this storm that is in the northern hemisphere in the Atlantic. A typhoon is essentially the same thing. That's just what they call them in the Pacific. And cyclones are also a name for these large storms in the Pacific. And this is when you have high and low pressure cells with wind and storm that create the wind and storm system. You know, if you imagine if you're in a bathroom and you've had a shower, you have a lot of steam in that room, and that's kind of high pressure. And then imagine if you were to quickly open the window or the door, and then the steam and the pressure would leave that room, and then it would exit out the window and out the door. And that's kind of a sudden drop in pressure. And this sudden increase or drop in pressure is what can lead to global storms. This is an example of Hurricane Irma compared to what was considered a large hurricane, Hurricane Andrew, that hit Florida or the eastern coast in 1992. Hurricane Irma was roughly 370 miles across, while Hurricane Andrew was only about 180 miles. So Hurricane Irma was a Category 5 hurricane at some points. It went up and down as most hurricanes do. And we were also, in addition to Hurricane Irma, we were hit by Hurricane Jose, Hurricane Mary, and Hurricane Harvey. So it's been a very busy hurricane season. Interestingly enough, the last several years we've had very few hurricanes. We've really gotten lucky over the past 6 or 7 years. So it might seem like we've been hit by a lot of hurricanes, and we have been this season, but we got pretty lucky the last 6 or 7 years with below average in number of hurricanes, and now we're having a well above average number of hurricanes. Most climate scientists believe that the number of hurricanes does not go up due to global warming, but warmer temperatures mean more water vapor in the air, and that leads to larger and powerful hurricanes with higher wind speeds and more rain. So global warming, most climatologists don't think increased the number of hurricanes, but they increase the size and force and moisture in the hurricanes. So we also have major global wind patterns in the Earth. There are relatively predictable patterns of wind in the northern and southern hemisphere, and relatively predictable ocean currents. In the northern hemisphere, north of the equator, you typically have what are called northeast trade winds that blow from the east to the west. And then as you get further up, roughly about the 40th parallel, that trend tends to reverse. And most of North America, we have winds that usually come from the west towards the east. And it's similar in reverse it's similar in the southern hemisphere as well. most winds tend to move from the east to the west, a little bit south of the equator, and then as you get past roughly the 40-45th parallel, they tend to reverse, and you get what's called the westerlies that push from the west towards the east. And there are also fairly common rain patterns called monsoon winds, and these are heavy rains that you get in certain parts of the world, usually about 10 to 15 degrees north or south of the equator. India is very famous for this, Vietnam, South Asia, where they have a wet season and a dry season. Usually the wet season is their summer, and you have very, very heavy rains, and then starting in October or November it dries up, and then during the winter you have relatively dry season with very little rain. So areas about 15 degrees north or south of the equator often have very wet summers and very dry winters. In addition to having variations in global wind patterns, you also can have variations in how much moisture certain areas get depending on mountains. If you have a large mountain range, what happens is moisture being pushed into that mountain range is pushed up into the mountains where the moisture cools, and then it comes down as snow and as rain. And then on the opposite side of the mountain range, you often on the leeward side, on the opposite side of the wind, where the wind is not hitting, the windward is where the wind is hitting, the leeward is where it's protected. You often have a much drier climate. A good example of this is Washington State. Seattle, Washington is fairly damp and gets a fair amount of rain. And then on the opposite side of Washington State, it's actually quite dry. Spokane, Washington, and Tacoma, Washington are fairly dry compared to the opposite side of the Cascade Mountain Range. So another good example of this would be in India, where you have the Himalayan mountains. Moisture comes off the Indian Ocean, pushes into the subcontinent of India. It hits the Himalayan mountains. It's pushed upward. It comes down as rain. Northern India gets a tremendous amount of rain. And then on the opposite side of the Himalayas, it's much drier, and you have large deserts like the Takama Desert and the Gobi Desert. So areas that are on the dry leeward side of a mountain range are said to be in the rain shadow of that mountain. So that explains the variation in many parts of the world where you'll have one part of land on one side of the mountain that's very dry, the opposite that's very wet. Another example is the South America. The Amazon basin is on the wet windward side of the Andes Mountains, and then you have a very dry desert on the leeward side of the mountains that's dry because the moisture all falls on the Amazon basin on the opposite side of the mountain range. Here's an example of the Atacama Desert. It is the driest desert in the world, and it's in parts of Chile. And you can see this is where the wind would come from, pushing from the equator towards the southwest. Then it hits the Andes Mountains and it's pushed up. It comes down as rain, and that rain falls into the Amazon basin, roughly this area here, very, very wet. And then on the opposite side of the Andes Mountains, you have this very dry desert. The Andes Mountains is the second tallest mountain range in the world after the Himalayas. It's also the longest mountain range in the world. And rain is so scarce in this desert that some people who live there have never seen rain in their entire life. They can't even remember when it last rained. That's how rare rain is in parts of the Atacama Desert. Now, when you have a very dry environment, and also when you have a very high altitude, pardon me, this can actually make it ideal for telescopes. The higher you are up on the Earth, the less atmosphere you have to look through to see into space. Atmosphere creates distortion. There's moisture, there's clouds, there's dust and pollution. So the higher you are in altitude, the better it is to have an observation area. So you have this area that's relatively cold, very, very dry, very high up, and it makes it an ideal location for this massive multinational telescope operation center called ALMA. This is Atacama Large Millimeter Submillimeter Array, called ALMA for short. This is a series of telescopes that are run by international science agencies that observe space. And this is so high up, sometimes the people who work in them actually have to wear oxygen masks in order to move around because the air is so thin. They don't exactly, these aren't telescopes that you would look through like you would think of like a piece of glass. They collect information and noise basically from space, and they take that information and they convert it into, information on a computer screen that scientists can then look at to learn more about space. So you don't get to look through a telescope when you're working there. So there are many different climate regions in the Earth. The main ones are A, B, C, D, E, and F. This classification system of classifying different climates by letter is called the Köppen system, named after an Austrian geographer in the early 20th century. A climates are tropical, and that would include areas generally around the equator. You can see here parts of the Congo and the Amazon basin would be tropical. Then as you get further away, you get into areas that are dry and deserts and steppes a little bit north or south of the equator. And then as you get a little further away, you get into what are called C, mid-latitude climates. These are mild mid-latitude climates. The southeastern part of the United States, around Georgia and South Carolina, would be an example of this. And then also parts of California and the Pacific Northwest would be classified as mid-latitude, mild mid-latitude climates. As you get into the interior of different continents, you have more variation in temperature, 4 distinct seasons, and then you have a continental climate. Michigan is an example of that here, and most of Europe is also a continental climate, although parts of it along the Mediterranean are Mediterranean climate, which is a type of mid-latitude climate. And then as you get further away still, you get into polar climates, which includes tundra and ice caps. Ice caps is an area permanently covered by ice all year round, and tundra is an area that's very cold with very little vegetation, short stubby grass because of a short growing season, and relatively cold, desolate, usually fairly dry. It's important to know kind of the basics of these different climates. This is an important concept to understand. When we talk about different regions, we will talk about the different climates within each region. So make sure you understand the basics of wet climates, dry climates, mild mid-latitude climates, continental climates, polar climates, and then complicated highlands. Climate F, complicated highland, is an area that's very mountainous, so there are massive variations in temperature and climate depending on where you are in the mountain and which side of the rain shadow you're on, and so on. So remember the basics of this climate classification system: A, B, C, D, E, and F. So there has been significant climate change and a warming of the climate, especially since the mid-20th century. Temperatures on average are getting warmer. Ice caps are melting in Greenland and in Antarctica. Sea levels are rising. Houston has already had a significant rise in sea levels compared to what it was about a century ago. And we will have and have seen more extreme weather events, meaning possibly more hurricanes, more likely the same amount of hurricanes, but they'll be more severe, possible water shortages, and more droughts. So climate change is creating extremes in weather conditions, and the effects are still not entirely understood. It will almost certainly lead to rising sea levels and other major problems. And of course, sea levels rise because as ice in Greenland and Antarctica melts, that ice that was locked up in ice and above the ocean is now melting and falling into the ocean. And that can lead to increases in sea level. Pacific islands, especially low-lying Pacific islands, are especially vulnerable to rising sea levels. The country of Kiribati is a series of islands near the equator, some of whom are only about 6 feet above sea level at their highest point. And the island of Tuvalu, which is in this country, only has its highest point about 5 feet above sea level. And what that means is during high tides and storms, it's possible for almost the entire island to be submerged. And in addition to that, many of these islands have fresh water sources that can become contaminated with salt water if water levels rise. Some of these islands may eventually have to be evacuated. Australia already has agreements in New Zealand with many small Pacific islands that if their countries and their islands become uninhabitable, they are allowed to emigrate to New Zealand or Australia as climate change refugees. What's more likely to happen is they'll just have to change how they live on the island. They'll have to live in homes that are elevated. They'll have to get water from maybe rainwater collection or by absorbing it out of the atmosphere rather than getting it on the island. So there are ways you can adapt to rising sea levels, but nonetheless, it's a major problem for many low-lying Pacific islands. Here's a map of National Arbor Day Foundation for their hardiness zones. This is an organization that promotes gardening and a love of nature and flowers and the outdoors. And if you look at their 1990 map compared to their 2006 map, they show that different zones of hardiness have been migrating north lately. Basically, climates have been getting warmer. So the climate of Jackson, while we were in zone 5 in 1990, we are now considered to be in zone 6 as of 2006. So we have a climate, at least as far as they're concerned, similar to what southern Ohio might have been just a few decades ago. Here's another map that shows Michigan's geographic center, which is roughly around Cadillac, Michigan. And some scientists are predicting that in the year 2114, the average temperature in Michigan's geographic center could be similar to what it was in Cincinnati, Ohio in the year 2014. So it's been estimated that average temperatures in Michigan could get warmer and warmer. And judging by the last few days, it's been September and October, and about a week ago we had several days in the 90s. And even now it seems awfully warm for October. So based on average temperatures, this is what some scientists are predicting Michigan's climate might be like in about a century, similar to southern Ohio and northern Kentucky. So climate change is caused by many different things, but mostly a release of greenhouse gases into the atmosphere, such as methane and CO2, from anthropogenic causes, meaning human causes. Anthropogenic means something that is human caused. Anthro means people. For instance, anthropology is the study of people and their cultures. And coal-fired power plants and natural gas is these power plants, along with cars and buildings, are releasing significant amounts of CO2 and greenhouse gases into the atmosphere. It's also thought that the burning of rainforests is also releasing CO2 into the atmosphere. Carbon that is locked up into trees is released when they're burned, and now some scientists think that rainforests are actually contributing to global warming more than helping it, because so many of them are being burned at a very fast pace. And as you can see on the top right, it shows temperature changes going back 1,000 years of changes in temperature, carbon emissions, and CO2 concentrations. And as you can see, scientists can predict how much CO2 is in the air by looking at small bubbles that are trapped inside Antarctic ice. They have these massive machines that drill what's called a core deep into Antarctica. They drill down into the ice, they pull up a cylinder of ice, and then there are little bubbles in these cylinders, and they can predict with a great deal of accuracy what the atmosphere was like centuries ago based on doing tests on these bubbles in ice. And the information that we've collected is that there's no doubt that CO2 is being significantly increased, and the level of CO2 has significantly increased in the last 1,000 years compared to how it was. You can also tell what temperatures were like by looking at tree rings. In a year that's cold, trees won't grow as much, and the ring is smaller than a season where it's warmer, and then the tree grows more. So when you have tree rings where the bands are very closely linked together, that means that was relatively cold time for the tree, and then if they're wider, it means the tree was able to grow more and that it was most likely warmer during those years. So global warming can create a vicious cycle where warmer temperatures can release methane that is naturally trapped in the permafrost of the Earth, basically ice that's permanently frozen. And some of this ice that's permanently frozen has bubbles of methane trapped in it. And as it warms up, it releases this methane, and then that gets into the atmosphere. It contributes to even more global warming, and it can create a vicious cycle where methane emissions increase greenhouse gases. Greenhouse gases increase the warming of the tundra. Some oceans become warmer. That releases more methane, and it can create a vicious cycle of increased global warming because of methane emissions. In addition to warmer temperatures, air pollution is also a major cause of health problems with people around the world. China leads the world in greenhouse gas production because of large amounts of coal-fired power plants. They are trying to move away from it, but China, especially Beijing, is notorious for very poor air quality. India also has many cities that have very poor air quality. The picture on the top right is the Forbidden City in Beijing on a particularly cloudy, hazy, smoggy day. And the bottom left are runners in China wearing masks to protect themselves from the poisonous air while they run a fun run. Doesn't look all that fun to me. And then in the bottom right, it shows a picture from space of eastern China, and you can see massive amounts of smog and pollution that are easily visible from space, caused by mostly coal-fired power plants and other things that create pollution. It's been estimated that as much as 20% of the air pollution in California might be traced to China, and then the pollution just drifts over the Pacific Ocean and hits the western part of the U.S. China has pledged to produce 20% of their energy from renewable sources by 2030, and they may actually be able to achieve this because the cost of solar and wind has been rapidly dropping since roughly 2008. It just gets cheaper and cheaper as production is ramped up and increased. This is an example of Beijing. In order to honor the 70th anniversary of the end of World War II, China and the U.S. were allies during that war. China, the United States, the Soviet Union, Great Britain were fighting against Germany and Italy and Japan, the Axis powers. In honor of the 70th anniversary of the end of World War II, Beijing shut down all the coal-fired power plants, closed the factories so they could have a nice parade. And the top picture is a picture from the CNN's office overlooking downtown Beijing the day of the parade. And then the bottom picture is 2 weeks later when they went back to business as usual, and they were right back to putrid, horrible air pollution. Again, China's bad and India's bad or worse. New Delhi is also notorious for its air pollution. It's been estimated that if you were to sit outside for 8 hours in China on a bad day, it might be the equivalent of smoking 2 or 3 packs of cigarettes. That's how poor the air is in China some of the time, especially when it's cold out. So there have been international efforts to limit emissions. The International Panel on Climate Change was created. The Kyoto Protocol was an agreement where different countries got together in Tokyo, Japan during the late 1990s to try to reduce pollution. And then in 2015, there was a major 2015 Paris Climate Agreement where different countries got together and set standards that they themselves would enforce. Nothing would be binding, to try to bring down global warming and bring it to 1990 levels of pollution. President Trump has said the U.S. might leave the Paris Climate Agreement. It's not entirely certain what will happen, but many states have said that, states and cities across the U.S. have said that they will, on an individual basis, a city basis or a state basis, uphold the Paris Climate Agreement that the U.S. agreed to in 2015. As the cost of renewable energy keeps dropping, the need for fracking natural gas and coal that gives off greenhouse gases might become less relevant. And the best thing we can do to curb climate change is to push for more and cheaper renewable energy. So again, this is the 2015 United Nations Climate Agreement. This agreement was to limit global warming to less than 2 degrees Celsius compared to pre-industrial levels. So even these countries at this meeting agreed there's almost no way to stop global warming, but they like to keep it under 2 degrees by the end of the century compared to pre-industrial levels, roughly say 1800, and zero net anthropogenic greenhouse gas emissions by the second half of the 21st century. So essentially, no more greenhouse gases by the mid-20th century compared to what it would have been during the pre-industrial era. So these are different natural regions of the Earth. These are called bioregions. This is another way of classifying the Earth, somewhat like we saw earlier, like the Köppen model, except this is a little different. You can kind of think of them as sort of the ACT versus the SAT. The Köppen model is a little more detailed, but a little more complicated as well. And the bioregion model is a little simpler. Different bioregions. First of all, a bioregion is an area that has similar plants and animals, such as a prairie or a desert. And then a novel system is an area that has a large amount of man-made, a man-made environment. Like a large city would be considered a novel system, an unnatural system. And another example of that might be massive agricultural areas. Anything that is not natural would be considered anthropogenic or a novel system or region. But these are the natural regions of the Earth, and they include along the equator tropical rainforests, then tropical seasonal forests. Those are areas that have a wet season and a dry season. Then tropical savannas. Those are a little drier than tropical seasonal forests. Then deserts and grasslands. Then Mediterranean shrubs and woodlands. Temperate deciduous forests. That is what Michigan would be. Evergreen forests. Those are areas that are a little colder, that have a lot of pine trees. And then tundras, which we've talked about earlier. So North America has a combination of deserts and grasslands, tropical rainforests, pretty much only in Hawaii, and then some savannas in southern Florida, but a large number of temperate deciduous forests and deserts and grasslands in the center part. So we'll talk a little more about bioregions. Some of the bioregions are under threat because of human development. Forests are being cut down to sell their wood. Forests are also being burned to clear land for cattle and to clear land for farming. Sometimes forests are being cut down at a small individual level. Informal poachers who cut down logs on their own and then sell them are making money doing that. So a lot of the natural environment, especially rainforests and other forests, are in danger as they're cut to make waves for other purposes. This is a picture of a tropical rainforest being destroyed in sub-Saharan Africa. Some of the areas are being cleared to make way for specific crops. This is cocoa, which is what chocolate is made from. Responsible forest management is needed to preserve some of the rainforests, but very often massive plantations like rubber plantations or cocoa plantations or other plantations are simply more profitable than a rainforest is. So, cattle generates more tax revenue and employs more people than forests do. So there's pressure to clear forests and turn it into something more economically productive. Some countries have tried to preserve forests and promote ecotourism. This is what the U.S. does with our national forests. Yellowstone National Forest was the first national park in the world. It was made a national park in the 1870s. At the time, people thought it was a crazy idea. Why on earth would anyone need to preserve this incredibly remote patch of wilderness? But looking back, it was a very good idea and an example for the rest of the world. So ecotourism can be a way to help preserve forests, but it's still sometimes difficult to hold back the encroachment of people and the conversion of forests into something else. So a tropical rainforest covers about 7% of the world's land area, so not all that large. They receive about 70 to 150 inches of rain per year. They're a very diverse bioregion. They have a very vast amount of plants and animals in them, and they're vulnerable to deforestation for many reasons that we've discussed. Now, tropical seasonal forests and tropical savannas are usually areas that typical tropical rainforests are near the equator, a little north or south of the equator, you often have these areas that are still warm, still receive a fair amount of rain per year, but the rain is seasonal. They have wet seasons and dry seasons. The picture on the bottom left is an open tropical savanna in Brazil. And the picture on the right is a tropical seasonal forest in India. Many of the wide open grasslands in Africa are tropical savannas. That's where you have the exotic animals such as buffalo and lions and elephants and all those interesting animals. Those are in tropical savannas for the most part. And then deserts, of course, are generally areas that receive 10 to 5 inches of rain or less per year. This can vary, of course, from year to year. The largest non-polar desert in the world is the Sahara, which is pictured on the left in northern Africa. Technically, Antarctica is classified as a desert, although it's considered a polar desert because it's even drier than the Sahara is. There's very little, there's no rain there. There's very little snow. The ice is there. It has been there forever, and it's it's the driest of all the continents. But the largest non-polar desert, excluding Antarctica, is the Sahara Desert in northern Africa. The Sahara Desert is about as large as the continental United States. Interestingly enough, cacti that we are so used to seeing in the Americas is unique to North and South America. They don't have cacti in Africa or the Middle East or elsewhere. Deserts are growing. Basically, all across the world, underwater aquifers and underwater resources are being depleted, and forest degradation is leading to forests being destroyed, and deserts in China and elsewhere are slowly spreading. It's also happening in parts of Africa. So warmer temperatures might also be leading to the increase in deserts. So deserts are of course very bad. They're caused by soil erosion. They're difficult to reverse, and all across the world, many of the world's deserts are growing. Beijing is vulnerable to sandstorms. In 2010, Beijing was hit by 2 massive sandstorms in 1 week because the Gobi Desert north of Beijing is rapidly growing and moving further south. Prairie and steppes are areas that are not wet enough to sustain large amounts of trees. You typically don't see trees in prairies or steppes unless perhaps they're along rivers, but they are moist enough. They do get enough rain to support grass. So they typically have between 5 inches and 30 inches per year. There are prairies that are wetter that might get 25 to 30 inches per year, and then there are prairies that are drier that get less. Steppes and prairies are similar. Steppes usually are wide open grasslands that have shorter, stumpier grass. They're common in Mongolia. And prairie is what we think of Kansas and Nebraska in their natural state, where you have more moisture and taller grass. And then you have very wide open prairies that many of which have been converted into farmland now. But prairies and steppes, wide open grasslands that get about 5 to 30 inches of rain per year. Mediterranean shrubs and woodlands are where they would be considered a mid-latitude mild climate. California and Italy would be examples of these. Mediterranean climates usually get more than 10 inches per year. They have a wet winter and a cooler winter and then a drier summer. This is the opposite of what southeastern states in the U.S. get. They have wet summers and dry winters. In Mediterranean climates, that's reversed. And again, Italy and California are examples of this climate. And temperate deciduous forests, these typically have a year-round fall of 30 to 60 inches of snow or rain. Michigan is an example of this. Germany is an example of this. Typically warm summers, cold winters. Again, North America and Europe have this kind of climate. They have rich soils. Michigan and Wisconsin and Minnesota have very rich soils because glaciers that used to cover much of the Midwest retreated about 10,000 years ago and left deposits of very rich soils when they retreated. So that's partly why we have a very good farmland in the upper Midwest. This is a picture of New England deciduous forests. And the way to keep deciduous forests and coniferous forests separate is coniferous forests have cones, meaning evergreen trees, and deciduous forests don't, or deciduous forests drop their leaves. So oaks and maples are examples of deciduous forests, and pine trees are an example of evergreen forests. So an evergreen forest is also sometimes called a boreal forest or a taiga. In Russia, they usually refer to them as taigas, and in Asia. And these have average temperatures below freezing for at least 1 month. This is what kind of separates them from deciduous forests, which are a little warmer. Annual precipitation around 40 inches. And again, these are sometimes called boreal forests or taigas. Isle Royal is an example of a boreal forest. They have lots of pine trees. It's beautiful. I was there backpacking about 8 years ago. They used to have 3 separate packs of wolves. Now I think the wolf population has been reduced to about 1 or 2. Scientists are thinking about reintroducing wolves because they're afraid without wolves the moose population might explode and that might cause some problems. But beautiful national park in the middle of Lake Superior, great for backpacking and camping, very natural and beautiful, and an example of a boreal forest. Evergreen forests or boreal forests, like many forests, are vulnerable to logging. The evergreen trees often have soft, light wood that's good for carving and good for making into construction equipment for homes and so on. It doesn't easily warp, and many parts of the Pacific Northwest, especially and elsewhere, being overlogged. And when you cut down the trees, that can lead to erosion and mudslides, and that can lead to contamination of water sources. So bad things can happen if you have a destruction of forests. Habitat loss of forests all across the world is happening because of rapidly expanding cities. Roads are being built, airports are being built, and anytime the human footprint grows, it often has to cut or pave over the natural world around it. And then the tundra, these are areas to the far north or south near the poles. And this is a picture of an Arctic tundra in the north. You can also have mini tundras in alpine regions, mountainous regions. These are areas that are primarily treeless and they have short growing seasons, and they can store vast amounts of methane. This is a potent greenhouse gas that's more potent than CO2. That's often trapped in the ice and the soil in these areas. And as the soil melts and warms and the ice melts, it can release this methane gas that can further speed up the cycle of global warming. And then, of course, ice is such as Greenland and Antarctica areas that's just completely covered by ice year-round. Antarctica is not lifeless. If you've ever seen March of the Penguins, you know that there are penguins and some seals in Antarctica. So even areas completely covered in ice still can have some life. So as the Earth becomes warmer and the Earth's population grows, the human population grows, this can lead to water shortages and water scarcity and water stress, which is a broad term for different kinds of water shortages. North America has had some problems with water stress, especially in California. The Sahel, this is a region of Africa south of the Sahara Desert, but before you get to the warmer equatorial tropical regions, a transition zone between the two. This is an area vulnerable to water shortages, and India has also, and Pakistan, has suffered from water shortages. So in this particular map, the areas in orange are areas of predicted water stress by the year 2025. And as you can see, it's all over the world. 70% of the Earth's surface is covered by water, but only a small amount of that is fresh and accessible. The rest is locked up in ice or underground and inaccessible. So California had a very severe 5-year drought. It has eased somewhat about a year and a half ago, but the danger of a drought is still there. On the bottom right is a picture of a large reservoir in California, and you can see where the water typically historically has been, where the tree line is. And sometimes people call this a bathtub ring. And because of a lack of rain and snow, this reservoir has been declining rapidly. Again, this has been reversed to some degree, but the area, California, is still vulnerable to water shortages. Qatar is a wealthy Middle Eastern country on the Gulf. that has invested in a desalination water plant. This is basically a massive power plant that takes salt water, pulls the salt out of it, and then converts it into fresh drinking water. This is a good way of producing drinking water, except it's expensive and it uses a tremendous amount of energy. So Qatar is actually trying to move away from using oil to power the desalination plant and towards using solar power to power the desalination plant. After all, the less oil they use, the more they have to sell to the global market. So this massive desalination plant is currently in the process of switching over and becoming 100% solar, and should be 100% solar in the near future. But countries in the Middle East where water is scarce and that have a fair amount of oil money, such as United Arab Emirates, and where Dubai is, and Qatar, have invested in desalination plants. In addition to having a lack of water available to you, sometimes water sanitation is a problem, meaning you might have water that's available, but it is not clean to drink. Even in the U.S., we've had a problem in Flint with water sanitation. Different pipes were contaminated with lead because they were not properly treated first with a chemical that might have prevented lead from leaching into the water. And water pollution can be very dangerous. Women are sometimes, it's usually women who have to get water, are sometimes forced to carry water from a clean, safe water source miles away from where they might live. And it's particularly harmful to infants and children. Smaller bodies are more vulnerable to contaminated water because their bodies are still developing and smaller. So water sanitation is a major problem throughout the world. Also, water access. Sometimes there might be a water source that's available, but it's controlled privately, and it's difficult to get access to it. If you don't have the money, you might not be able to have it. Again, this is something that we have in Detroit as a major problem. Many people in Detroit can't pay their water bills because they simply don't have the money to pay for it, and then their water is cut off. So in the Great Lakes states, where we have plenty of water, there's a problem of water access because some people cannot afford their monthly water bill. So this is another problem around the world where you might have water available, but you might not be able to afford it or have access to it. Global energy sources. Energy, like water, is a major important factor in the global economy and where people settle. There's a major uneven distribution of energy resources. Some countries are very wealthy, like Qatar, we talked about earlier, and some countries are relatively poor. Yemen is an example of a Middle Eastern country with very few natural resources, very little oil or anything to export for wealth. And also, often you need very complex technologies to take advantage of natural resources. Energy is a major factor in international politics, and the U.S. has a very large military presence in the Middle East, partly to protect our access to Middle East oil that our economy is dependent on. On the bottom left, that is a solar power plant in Morocco. Morocco is a country in North Africa, and they have tried to become a major source of solar power that they can then sell perhaps solar energy to parts of Europe. So they want to be kind of the Saudi Arabia of solar energy. So they're starting to build up large solar stations and solar plants in their country that they can sell to other countries. Renewable energies are forms of energy such as wind and solar and geothermal and hydroelectric, meaning water from dams. It is currently probably about 20% of the U.S. energy source. Michigan gets about 10% of its energy from renewable sources, mostly wind and hydroelectric power, and a very small amount of solar. But there are some states that have renewable energy standards. In other words, they have state laws that require them to get a certain amount of energy from renewable sources like wind and solar by certain dates. Michigan had a law that required us to have 10% of our energy from renewable sources by 2015. We've reached that goal, and now we have a new goal of getting 15% of our energy from renewable sources by 2025. So renewable energy portfolios have been very important in increasing renewable energy in the U.S. and around the world, and that has helped to drive down costs by building up the economies of scale and increased efficiency. There have been in Texas, they have been known to get up to 40 to 45% of their energy from renewable sources at times. usually in the spring and the fall when consumption demand for energy is relatively low and their winds are fairly strong. So again, renewable energy would be wind, hydroelectric power, solar power. The costs are coming down very rapidly, and it's being implemented and growing very rapidly around the world. Fossil fuels are generally oil that we're fairly familiar with, and also natural gas. There's been a natural gas revolution because of a process called fracking that has opened up natural gas all across North America to areas that where previously natural gas was inaccessible. And fracking happens by basically, as you can see in the picture here, driving down a large well into an underground rock formation that has natural gas trapped in it. And then this drill is tilted sideways so it is parallel with the surface of the earth, and then lined with explosives. Then there's a big explosion underground, and that cracks and frees up some of the natural gas that's trapped underground, which is then brought up through wells. So this has led to a significant increase in the amount of natural gas the U.S. has, and a drop in the price of natural gas, which is good because natural gas by most accounts is cleaner than coal, and many states have been shutting down coal-fired power plants and replacing them with natural gas. But natural gas has problems because the natural gas can leak into underground water sources, and that can cause water sources to be contaminated with natural gas, and causing, in extreme situations, people who have faucets that can catch on fire because of natural gas in the drinking water. So parts of Pennsylvania and North Dakota have had lots of fracking and lots of natural gas. This has helped their economies in some ways, but also caused environmental problems. Also, the huge increase in natural gas has actually driven down the cost of natural gas to the point where sometimes the well are not. There's just an oversupply, and they're not economically feasible anymore because there are too many of them and the price is too low. So natural gas has actually declined slightly in the last few years because of an oversupply. And again, we talked about renewable energy a little bit before. Solar and wind are examples. Much of the American prairie has huge, massive wind turbine farms. They're called wind farms. Gratiot County, Michigan has these as well as the Thumb region. And solar energy is increasingly becoming common around the world. Germany has a climate very similar to Michigan, so it's not exactly ideal for solar, but they've invested heavily in solar energy because they don't want to be dependent on Russian natural gas. Russia has a history of cutting off natural gas supplies to people that have been doing things that they don't agree with politically. In other words, they use natural gas as a political tool. And Germany does not want to be dependent on the whims of Russia for its energy. So they've invested heavily in solar, even though it's not an ideal climate for it. So in the future, demand is expected to increase for energy by about 40% by 2030, mostly due to increased demand in China, India, and Brazil. China is the largest nation people-wise in the U.S. India is the second largest, both of which have about 1.2 billion people. Brazil is the fifth largest country in the world population-wise, and more developed countries are expected to have a slower demand for energy. You can reduce energy consumption with more energy efficient homes, light bulbs, cars, and so on. More walking, more biking, just anything that reduces electrical use is a way of reducing demand for energy and fossil fuels. Programs that promote walking or biking or even living close to where you work can reduce a country or state's demand for fossil fuels. So let's go over a couple questions real quick, kind of go over chapter 2, do a quick review like we did before. What is the largest physical feature on planet Earth? You should be able to tell by looking at a picture of any map or globe, and the answer is C, the Pacific Ocean. This is far and away the largest natural feature on the Earth. It covers almost more than a quarter to possibly up to a third of the entire Earth is the Pacific Ocean. So in 2008, which country surpassed the United States as the largest emitter of greenhouse gases? And that would be China. China consumes a vast amount of greenhouse gases, a lot of energy, mostly from coal. They are switching over to solar and wind and renewable energies rather rapidly. So hopefully this will be a trend that reverses itself as they push towards new renewable energy. The term blank describes how long-term average atmospheric processes. That is, a long-term average atmospheric process would be a climate. Sometimes there's a joke that climate is what you expect and weather is what you get. Weather is, well, what it's like right now if you look out the window, while climate is kind of the long-term average of what typically the climate and the weather is like where you live. So we normally wouldn't have days in late September where it's in the 90s for days on end. That would be an example of a weather anomaly. The climate would be typically cooler than in the 90s during late September. Term used to describe an assemblage of local plants and animals is a bioregion. An ecozone is, or an ecosystem is an area that's usually smaller than a bioregion. The two can sometimes get confused. A bioregion would be an example. The Sahara Desert would be an example of a bioregion. Yellowstone might have its own unique ecosystem, which is a smaller area. So bioregions are larger. They can cover large portions of continents, and an ecosystem is somewhat similar, but a smaller micro version of a bioregion. Tropical rainforests are being blank in order to provide products for the global economy, and they are being deforested. Some tropical rainforests are being cut and the wood is being sold. Some are being burned to make way for cattle. Some are being burned to make way for plantations like palm oil plantations, but they are vulnerable and being destroyed at a rapid rate around the world. Distribution of volcanoes and earthquakes is closely associated with B, plate tectonics. The top picture is earthquakes in red. The bottom picture are volcanoes in yellow. And you can see they often are along different plate boundaries. Water stress is most common in what type of climate region? Not surprisingly, that it's most common in B, dry. That would be deserts and steppes. Deserts are typically a little bit above and below the equator. And the Sahara Desert is an example of a large non-polar desert. Lush grasslands are characterized this bioregion. So what bioregion has large lush grasslands? That would be C, steppe, very similar to a prairie. You can more or less use them interchangeably. Steppes usually have shorter grass and slightly cooler climates. If you have any questions, feel free to email me at wrenando@jccmi.edu. I've really enjoyed looking over assignment 1, looking at the different interesting places all of you have been. Many mentioned places right here in Michigan. Michigan has a lot of great places to visit. And again, if you have any questions, give me an email. If you would like to set up a video conference, you can also do that. Send me an email and we can set up a time to attempt a video conference. I actually haven't done that on my laptop before, but we should be able to do that. So just let me know if you have any questions. Have a good day.